remote repository in Maven. Um, now we are focusing on remote repository. Remote repositories refer to any other type of repository accessed by a variety of protocols such as file colon forward slash and https colon forward slash. These repositories might be a truly remote repository set up by a third party to provide their artifact for downloading. For example, repo.maven.apache.org. Other remote repositories may be internal repositories set up on a file or HTTP server within your company, used to share private artifacts between development terms and for releases. Here you can see this is a diagram which shows the defined flow in which Maven to resolve the dependency. Here you can see Maven read there should be a pom.xml and then build it. Then check, then Maven core check if artifact is in local repository. Then here the get artifact from remote repository and put download artifact in local repository, and then generate in the core generate files or create jar. So here Maven core is connected to pom.xml. Here this is the older version, so in 1.x this is project XML. Here 1.2 and onward it will be pom.xml. Then in step 2 here Maven core is connected to local repository, and step 3 Maven core interact with remote repository to HTTP, and step 4 Maven core is connected to local repository, and this is in JVM1 and this is in JVM2 the web server. Here you can see Maven repository architecture. Maven follows a two repository model wherein it maintains a local repository which is created when you execute the first Maven command. It downloads the dependencies from the remote repository into this local repository and then builds projects. Architecture looks like here, and Maven project is compiled. It checks the local repository for dependencies. If dependencies do not exist, Maven download them from the remote repository. Once dependencies are downloaded, they are installed once the dependencies are downloaded, they are installed in the local repository. Once all dependencies are met, Maven compile the code and the project. Here Maven project is connected to local repository. A default location $user.home /.m2/repository, and local local repository connected to remote repository here, and Maven is connected to remote repository and local repository. Downloads is connected to, is passed from Maven to remote repository, and install is passed from Maven to local repository. Here you can see Maven central repository. This is for to use and contribute to Maven central repository. This include that need dependencies for their own build core project that wish to have their releases added to the Maven central repository. Even if they don't use Maven as their build tool. Discontinue support for TLS version 1.1 and below as of June 15th of 2018, and discontinue support for HTTP as of June 15th 2020. Here you can see users. Maven is connected to local repository, plugin repository, and here Maven is connected to a local repository, and here Maven is connected to dependent public repositories. POM file is passed from Maven to independent public repositories. And this is repository and plugin repositories, and in independent public repositories include JBoss and others. And Maven is connected to central CDN, and central default is passed from Maven to central CDN, and Maven is connected to here mirrors and repository manager. Settings.xml is connected to passed through Maven to mirrors and repository manager, and mirror of command is here. A mirror of tag is there here, and repository manager is connected to private data and central repository and independent public repositories. Cache is passed from the central repository manager to central repository and independent public repositories. In central repository is here, and aggregation is passed passed to central data, and central data is connected to central CDN and mirrors. A publication is passed from central data to central CDN and mirrors, and here you can see central archetype catalog and central index. Inside mirrors you can see here iBiblio, Google, and rsync deprecated is passed from central repository to public project dedicated staging repositories. Here you can see XY and etc. And push is passed from public Forges multi-project staging repositories to central repository. You can see Apache, OSSRH, and etc. and public Forges multi-project staging repositories. Here this is the diagram which shows the defined flow in which Maven to resolve dependency. Here you can see the local repository. If dependency found, it will then retrieve dependency. It's connected to retrieve dependency, and local repository is if dependency not found, is connected to center repository. And if dependency is found in center repository, it is connected to retrieve dependency. And if dependency not found, center repository is connected went through remote repository defined whether or not. And if it is defined, then it's connected to remote repository. If it is not, it's connected to unable to find dependency. And here also if dependency is not found in remote repository, is connected to unable to find repository. And remote repository, if dependency found, is connected to retrieve dependency. Here you can see Maven 2 repository layout. Maven 2 repository layout format is the default layout since Maven 2, superseding old Maven 1 layout, where here the group ID as directory is group ID with dot replaced by /. For example, org /maven apache.maven. Here $sign after artifact ID is the artifact ID. The version is the version with some additional possibilities on a snapshot. Extension is the file extension, for example zip or tar.gs. Classifier is the artifact classifier when available. And checksums is a list of checksums algorithm, MD5 and SHA-1 by default. Maven metadata.xml file format is defined in Maven repository metadata module. .asc file is optional, may be requested in some repository like center repository, and is PGB detached signature file. Obviously a group ID, artifact ID, and version are defined in pom.xml, but what about classifier and extension? How they defined? Classifier and extension definition is completely different at artifact publication and usage times. At artifact publication time, extension and classifier are defined by plugins that create the artifact and attach them for publication. Some plugins provide configuration parameters to be able to override default values. For example, Maven jar plugins jar::jar goal produces by default an artifact with jar extension and empty classifier. The classifier goal parameter can be used to define classifier. There is no parameter to override the extension. At artifact usage time, extension and classifier are defined by dependency type and classifier definition in pom.xml. Here type jar by default define an extension and classifier, and classifier is optional to override default classifier defined by dependency type. Here you can see the central repository. It is one place centralized management of the Java library that was distributed and published on many sites. It is open to the internet and is available to everyone, and many Java build tools are standard reference destinations. By the way, it seems that the library developed by itself can be published in Maven Center repository. However, you will need to apply register library in the repository. Here you can see in the step 1 project A and project B and application and his module library, and here it's just the 2 here the local library, inside it Maven libraries are there, and here the step here the 3 the host 1 is connected to repository, interacts with remote repository. Inside it Maven libraries are there. Here the host 1 is interacts with host 2, and host 2 is interacts with remote repository here via here the example.com. For the host 1 interacts with host 3 via example.com, and host 3 interacts with remote repository here. Here the host 1 interacts with the host 4. Here the repo.maven /org/maven2/ here. Host 4 this for Maven 2 interacts with center repository, and it has Maven libraries here. Here you can see the Maven in remote repository, local repository, and remote center repository are connected via Maven here. These repositories interacts via Maven here. Here you can see there are 3 types of repositories in Maven. Maven does a lot of things behind the scenes. Before going to the concept of repositories, one should know about the relationship between Maven development environment and Maven repository. Maven repository explains about the Maven archetypes and types of repositories. Maven gets the knowledge from the repository, which has 2 types of information: archetype information and dependency information. Archetype is a model that defines a structure of a project. Archetype information has different types of project being created for the structure and the information about project. Maven initially generate archetype and get all the required information about the project being done. When maven archetype generate command is run in the command prompt for the first time, all the plugins are downloaded and gives the list of archetypes and information about the application. The input given to the archetypes are classified into 5 types: archetypes, group ID, artifact ID, version, and package. Archetype is the information given to Maven about the type of the project needed. Archetypes will differ based on the application to be developed. There are archetypes for J2E applications, Spring applications, Hibernate application, etc. In Maven repository, archetype is a good starting point for each application. Artifact ID is used to identify the output like files like Java and ER. Group ID is the exploratory ID used to group all the artifact IDs and give the identification to it. Version has a default snapshots, which is a piece of code to be released. Package is the location of source code. Based on the inputs provided, the Java class in the archetype will be assigned to Java class. There are 3 types of repositories in Maven: local repository, center repository, and remote repository. Central repository and remote repository. The searching sequence of dependencies in this repository will be the same. Initially, the local repository in the local repository, then the central repository, and then the remote repositories if given in POM file. The local repository contains the downloads of dependencies. Downloading one is enough even if there are multiple projects. Own projects can be developed in a local repository using install command. Local repository is placed in user's home directory by default. The location can also be changed using settings.xml. Here the XML settings, the local repository. Then, for example, give the path. Then, by default, the Maven searches for central repository for dependencies. There is no special setup required to use the central repository. The remote repository downloads the dependencies from a web server. It can be anywhere in the internet and even inside the local network. This repository helps in sharing the projects among organizations. To configure the remote repository in POM files, please follow the code. For example, it's called the XML repositories, then repository, then ID and the ID, then URL, then URL. Key points: Maven repository is a combination of archetypes and dependencies. Archetype gives the structure of the project. Local, central, and remote are three types of repositories. Maven always check the dependencies in the local repository. Here you can see the Maven local repositories and Maven remote repositories are inside organization internal network. Here the local repositories are local repositories interacts with Maven remote repository. Here the organization local network interacts with internet, and internet interacts with here Maven central repository. Here you can see the repository order. Remote repository URLs are queried in the following order for artifacts until one returns a valid result. The effective settings, then a global settings.xml, then user settings.xml, the local effective build POM, the local POM.xml, parent POMs recursively, and super POM, then the effective POMs dependency path to the artifact. For each of these locations, the repositories within the profiles are queried first in the order outlined in the order in the build profile. Before downloading from a repository, mirrors configurations is applied. If the effective settings and local build POM with profile taken into account can easily be reviewed to see their properties or order with MVN help effective settings and MVN help effective setting effective POM and -d verbose. Using an internal repository, using the internal repository is quite simple. Simply make a change to add the repository's element. If your internal repository requires authentication, the ID element can be used in your settings file to specify logging information. Here deploying third-party jars to remote repository as an example 2. To deploy third-party jar, use the deploy file goal under Maven deploy plugin. First, the Vagrant, for example, Vagrant provider, Vagrant FTP, Vagrant file, etc., must be placed to your $Maven $open brace maven.home close brace /lib. Then execute this command here. As an example 3, we can consider this one: http://report.1 maven.org./maven2/. This is the default repository for central repository. If the site is not available, finally it can be redirected to http://search.maven.org. Now we are considering interface remote repository in package org.apache.maven.api, a remote repository that can be used to download or upload artifacts. Now we are considering deploying snapshot artifact in base version artifact property in Maven remote repositories. So in case of snapshot deploy, version version transformation happen in form of this. Your POM locally usually contains a snapshot version in the form of a string and ends with snapshot. Constant string, for example 1.0 snapshot, but in case of deploy, this version is being transformed to a timestamped snapshot on the fly by Maven, and when you check the deployed result, you will see the artifact files does not end up with snapshot anytime, but timestamp and builder number. Also during the deploy, Maven will deploy required Maven v5 level metadata as well, that will describe for consumers the snapshot, how to reverse this process. In case of snapshot deploy, a version transformation happens in form of this, where the date in etc UTC time zone used in YYYMMDD.HHMMSS format is constant across deploy from the same session. Each time when Maven session is created, and the counter is increased from the previously deployed metadata, or if no remote metadata exists, is initialized with 1. Consuming snapshot artifact, if your project depends on snapshot dependency, the POM of your project usually contains version and value that ends with snapshot. For example 1.0 snapshot. Still we as we see above, remote repositories do not contain such versions, but only timestamps ones. Maven snapshots are moving targets, hence during resolution Maven will use the deployed metadata first to figure out Maven base version to version timestamp mapping, and only then will fetch the required files. In case of consuming snapshot, following transformation happens. Due to this interaction, the real file name of artifact, the version part, is figured from deployed Maven repository metadata. The snapshot artifacts are moving target. Each snapshot deployment has will deploy new metadata. Hence, we'll alter this transformation here. Maven will download different snapshot artifact. Note, it is possible to lock down snapshot artifact by using timestamp version in version field of the dependency, and will ensure Maven downloads always the same artifact. Is not moving target anymore, but Maven will still consider that dependency as snapshot, and all the fine print tuples, for example release plugin, will refuse to release such snapshot such a project. Now we are considering the the attribute distribution management in the project in Maven. This element is the root of the descriptor. The attribute distribution management attributes distribution information for a project that enables a deployment of the site and the artifact to remote web servers and repositories effectively. Type distribution management. Regarding API, the class distribution management in package API.model. This element describes all the pertains to distribution for a project. Is primarily used for deployment, artifact, and site produced by build. Repository deployment repository contains the information needed for deploying to the remote repository, which contains which adds a unique version property to usual repositories for download. With regarding API, we can consider class repository in package Maven.api.model. The repository contains the information needed for establishing connections with remote repository. Snapshot repository deployment repository contains the information needed for deploying to the remote repository, which adds a unique version property to usual repositories for download. With API, we can consider at non-null public distribution management.build snapshot repository, deployment repository, snapshot repository. In class distribution management.build in package Maven.api.model. Repository, the repository contains the information needed for establish connection with remote repository. Plugging repository, a repository contains the information needed for establishing connection with remote repository. Element repositories / repository asterisk the many in settings settings the root element of the user configuration file. This element many lists the remote repositories. This is a type list with type parameter repository. With regarding API, we can consider a class repository in package Maven.api.settings. Repository contains the information needed for establishing connections with remote repository. Now we are considering Maven CLI options reference. Here the option -u and -update -snapshots forces a check for missing releases and updated snapshots on remote repositories. Now we are considering supported by Maven project in available plugins. The plugin deploy the built artifact to the remote repository. This is type is built. With regarding API, we can consider public static final life phase deploy in enum lifecycle phase in package Maven.api.plugin.annotations. Now we are considering how do I deploy my jar in my remote repository in Maven getting started guide. Here is an example of SCP and username password authentication. For deploying jars to an external repository, you have to configure the repository URL in the pom.xml and the authentication information for connecting repository to the repository in the settings.xml. Here is example of using SCP and username and password authentication. Note that if you are connecting to an open SSH server which has the parameter password authentication set to no in the sshd_config, you will have to type your password each time for username and password authentication, although you can log in using another SSH client by typing the username and password. You might want to switch to public key authentication in this case. Care should be taken if using password in settings.xml. Default value is title /ssh/id dsa. Default is here title /ssh./id underscore dsa. Now we are considering guide to deploying third-party jars to remote repository. Then execute this command. Some concept of the install file goal of the Maven install plugin, where third-party jars are installed in the local repository, but this time instead of local repository, they will be installed both in the local repository and remote repository. To deploy the third-party jar, use use deploy file goal under Maven deploy plugin. First, the Maven provider Maven-ftp Maven-file must be placed in your Maven home /lib. Then execute the command here. Here the group ID, and here artifact ID, here the version, type of packaging, path to file, ID to map on the server section of settings, URL of the repository to deploy. Deploy a third-party jar with the generic POM. To disable this feature, you should set the generic POM argument to false. By default, deploy file generate generic POM to be deployed together with third-party jar. To disable this feature, we should set the generate POM argument to false. Now we are considering deploying third-party jar with the customized POM. Deploying third-party if the POM is already existing in third-party jar, you want to deploy it together with the jar, we should use the POM file argument to deploy file goal, deploy-file goal. See the sample here. Note that group ID and artifact ID and version and packaging argument are not included here because the deploy file goal will get this information from the given POM. Here the path to POM, path to file, ID to map on server section of the settings.xml, URL of the repository to deploy. Now we are considering deploying source jars. To deploy third-party source jars, packaging should be set to java-source, and generate POM should be set to false. Now we are considering guide to remote repository access through authenticated HTTPS. Now we are considering how to configure Maven access to remote repository. That site sits behind the HTTP server, which requires a client authentication and with certificates. The problem is there is a Maven repository of HTTP my.server.com/maven. This server only serves client authenticated through a SSL protocol by valid certificate signed by the approved certificate authority certificate, which can be called CA cert. In the simplest case, where the server is used to internally by the identified community of users, for example corporate intranet, the server certificate is a certificate authority as the server is used only internally. So we assume that we access the trusted certification of x.509 format stored in a file named here. Client certificate has been issued by some means not described in here in PKCS #12 format, which is the format that is accepted by browser, at least Firefox and internet Internet Explorer for import into their key store. This file is named here, and we assume that it is accessible when launching Maven. This file contains client's private key with which may be sensitive information, so it is secured by a password. The remote repository reference either through a pom.xml file here. Solution for Maven to use this repository, we take the 2 steps: create a store to hold server certificate using Oracle's key tool. And define properties to be used by HTTP client for finding certificates. The storing certificates, for this command, the following command line imports the certificates authority certificate into JK's formatted key. A key store named trust.jks, the trust store. Note that it should possible to import the full chain of certificates with only one root certificate being trusted, but author did not test it. Setting properties: the following properties must be set at the start of Maven to be accessible with HTTP client startup. javax.net.ssl.truststore, the path to the key store where trusted certificate are stored. javax.ssl. This is trust store, and other one is javax.ssl.truststore type. The type of the storage for this store may be either JKS default or PKCS12. javax.ssl.ssl, the javax.net.ssl.truststore password, the password protecting the store. javax.net.ssl.key store type, a key store, the path to the key store where users private key is stored. javax.net.xsl.key store type, the type of storage of this store may be either JKS default or PKCS. javax.net.ssl.key store password, the password protecting the store. Not all the properties must be set depending on the precise settings. Type of the store may left to default, password may empty. They may be set either on Maven's command line in .maven nrc file or in maven_opts environment variable. For setting the define in this document, here is an example .maven rc file. As an error example, we can consider this one occurred with the environment grail 2.5.x .x. An error occurred while processing Maven artifact task diagnosis. Error downloading Vagan provider from remote repository missing org.apache.maven.vagan.colon Vagan http://jar:1.0 beta 2. etc.